Alright, product rule. Product rule is used when two functions are multiplied together, hence the name. So we've been good so far with chain rule at spotting sort of an inside function, outside function, and now we're effectively spotting two that are next to each other. So we're looking for a multiple of two functions. In this first case here, the two functions we would typically call u and v. And you guys happy that this is one function of x multiplied by another function of x? Two things multiplied. And clearly you could expand them in and then do them the old-fashioned, the other way, but we can use that here. Here, we get a multiply sign, that's a pair of functions of x. Here, that's a pair of functions of x. First function, second function, first function, second function. And this leads us to our rule. So the blue box is straight from the book, and the blue box is saying when you have a function of x that is one function of x multiplied by another, u of x times v of x, the product rule is such: u dash v plus u v dash. Basically, it's the derivative of the first multiplied by the second, added to the derivative of the second multiplied by the first. The order you do this pair in doesn't matter, as long as the combinations are the same. So it's a matter of spotting the fact you've got two functions multiplied by each other, identifying them as u and v, and then setting the derivatives, and then using the formula. So, I'll show you some examples. Example 1. Now, if I was doing the exam, I would almost always set up a u and a v, just for simplicity's sake. You don't have to for marks, but it does prevent you from losing silly marks. In our case here, u is x squared, and v is 4 take 3x. Then to make your life nice and easy, we're going to set up the ingredients for the next bit. The next bit, I'm going to need a u dash, and I'm going to need a v dash. And then I want to use the product rule. So the product rule tells me that I can differentiate a function by doing u dash v plus v dash u. The rule might have written it the other way around, but that combination works. Then it's a matter of just stitching the ingredients into the rule. So f dash x is u dash, cool, 2x. V is the original, put in brackets, 4 take 3x. Plus v dash, right there, minus 3, brackets u, x squared. And are you guys happy that is u dash v plus v dash u? Clearly, it's not that pretty. We would never really write a plus or minus next to each other, you would just write that as a minus. You would also recognise that that brackets isn't really needed. So this is, right, you'd get your marks. It isn't what the answers would say. The answers would have a minus there and they wouldn't write the brackets there. But it's a matter of find your u and v, differentiate them, stitch those 4 ingredients into a rule. Then there might be more steps in the question, but that's how you differentiate it. So that's the derivative of that function. If you guys wanted to, of course, you could expand that in and differentiate each proportion, like you would have done in year 11, and it would actually work out to be the same as this. But you'll see in some rules, using the product rule is much better. So for example here, there's no way you could expand x cubed under that square root. There would be no way to expand and simplify this. Instead, we're going to grab our u, and we're going to grab our v. U is what, x cubed? V is root x plus 1. U dash.
Isn't it x plus 3?
Isn't
it x plus 3?
Thank you. V dash is a half x plus 3 to the minus a half. Now, the nastiest trap about this, and I haven't done it in this question, but can you tell me what I would change if there was a 2 there? If there was a 2 there, let's do it on alternate universe, my v would be root 2x plus 3. And therefore to differentiate this, we use the chain rule. Because this is really, v is really equal to u to a half, therefore v dash would be a half u to the minus a half times u dash, which is a half 2x plus 3 to the minus a half multiplied by 2. So that there is the chain rule from the derivative of the inner function. And it is very, very common to combine product and chain, meaning one of the rules here as a product actually requires you to get from v to v dash using the chain rule you just used. In here it doesn't matter, because the derivative of x is just 1, so I'm throwing out a times 1. But in the next example I think it does matter, and for plenty it will. When you do this setup, bear in mind, to go from one to the other, it's pretty common to have to use the chain rule. So it's quite common we're going to use combinations of these rules to do the derivative. Yes?
If you have to use both, you still use u in both.
It is weirdly confusing. Some people go with a for this one over here, because otherwise, yeah, you've already used the u. How you do it is a bit up to you. As in, the examiners wouldn't really expect to see that portion. All they want to know is get from here to here. How you do those intermediate steps is up to you. So you can use an a for the internal one, and let's say v equal a to the half, and then differentiate a and multiply by the derivative of a if you want. So the actual function here, once you've set up the 4, it's just a matter of writing it down in order nicely. U dash v plus v dash u and that's it.
Can you have the 2x plus 3 inside the bracket, or is
No,
right, sorry,
the 2 was just my mythical example.
Yeah, sorry.
If we started with 2, then it would be there, yeah. Alright, last example, and I think we do actually use the chain rule here. Yes?
How do you know straight away that you need to use the chain rule?
Years of practice. I don't know. I can't give you a better answer than that. Within about a month, you will know straight away you have to use the chain rule. The reason I know is because that half is going to be one of the functions, and I differentiate this function with an inner and an outer.
Okay.
So you see how there's like a split of 2 of them. This one definitely has an inner and outer. That one doesn't have an inner, so that one's going to be simple. This one's going to be a little more complicated. And you're going to get very quick at picking it. Yes?
How come with that one there wasn't an inner and an outer?
The kind of was, the inner is x plus 3. The good thing is when we differentiate x plus 3, the derivative of that is 1. So if I was being strict here, I could have written it times 1, because that's the derivative of the inner function coming out. But I was a bit slack. So yeah, you're right, that should have been a little times 1 there. Alright, this one here, are you guys happy that we can see u as 6x cubed and v as 2 plus 4x to the power of 7? Right. In order to make the product rule work, we need our u dash and our v dash. U dash is easy, it's 18x squared. V dash is harder. So I'm just going to say, in this case here, v equals an inner function and an outer function. So and how you do this is a little up to you. I'm not going to use u again, we'll go with this version, use 7a rather. So really, v is a to the 7. And therefore, I'm going to say v dash is 7a to the 6 multiplied by a dash, where a is this sort of internal bit here. So then it's the chain rule which we've just been practicing. V dash is 7 lots of 2 plus 4x to the 6 multiplied by 4. Are you happy that the inner function throws out a 4? Cool. Yeah, so as we practice product rule, you'll really be practicing chain really very often. Then we need to stitch them all together. F dash x is u dash v. It's kind of like a hot cross pattern. u dash v, so 18x squared bracket 2 plus 4x to the power of 7 plus v dash u. Now, if you want to be fancy, that 7 and that 4 and that 6 are all going to multiply together. I can't do 7 times 4 times 6 in my head, so I'm just going to split it like this. I'm going to say 6x cubed multiplied by 28, 2 plus 4x to the 6. So I've just combined the 4 and the 7 and put it there. Really, if you could, great. If you can, and then that's ugly, but I can't do the mental arithmetic. You guys are very welcome to multiply the 6 and the 28 together and just make it look a bit nicer. But that's the answer. And that looks long. And this is why in the methods course you'll get marks for working and there's multiple marks per question, and it's really why doing the working counts, because I'm not expecting you to go from this to that in your head. So please don't try to do it in your head. There is these supporting lines, the U and the V, and then more supporting lines to get the V dash if needed. Feel free to use those supporting lines. It's not a mental arithmetic quiz where you're trying to go from there to there in your head. Does that sort of make sense? Yeah, so these are working lines to really help you. And you will get quicker at doing them, but even at the end of the year, you'll still need those working lines in there.
And we probably not need to simplify it.
No.
Or
No, you wouldn't need to simplify that. I mean, I guess you could factorize out a 6x squared bracket 2 plus 4x to the power of 6. You could take a large common factor out the front if you felt like it. Sure, no, I don't think it's really needed though.
yeah.
Is there another example, or are we on to questions? We're on to questions, lovely. Alright, for exercise 2D, question 1, there's no chain rule. Question 2, there is chain rule. So if you haven't finished the chain rule questions, go on to this anyway, because you keep practicing the chain rule, and then go back to finish the chain rule questions afterwards.